Let us continue talking about the hash table using open addressing to solve the collision problems. In this class, we want to discuss three most major open addressing methods, starting with the linear probing, which is going to be the easiest way. So before we go into the formula, let's try to understand it by using an example. This is the example I want to talk with you guys. So we have this big table, and then we try to see what's happening at each operation. So if you understand correctly, you can see that we're creating an array with a space of 8. So there are 8 available spaces. While we try to do the very first operation, store 9, we will want to put 9 as the primary key into the array that we have generated. The hash function is going to be the k mod 8, k indicating the value that you want to store. And therefore, it's super easy. When we have a store value of 9, we're feeding into our hash function 9 mod 8 equals to 1. If you have any doubts on what is the mod operator, try to understand it correctly. Again, it's try to get the remainder value after the division. So in this case, 9 mod 8 will get a value of 1. So what it will do is that it will try to look into the index of 1 and see if you are able to put in there. Since there's nothing, you would be successfully putting 9 over the location. One more detail I want to tell you guys is the number of probings over here, that indicating how many times that you try to put the value into the spot that you have analyzed. And basically, by looking into this operation, we look into the index of 1, we found it, and therefore the number of probe equal to 1. So that is the first operation. And then the next value would be store 21. So when we want to store 21, we would try to see 21 mod 8 equals to 5. Again, if you have any doubts why 21 mod 8 equals to 5, try to find out correctly. So what it will happen is that you can see originally 9 is already occupied the index of 1, and it doesn't matter because what value of 21 that we want to map is at the index of 5, and it is available, so we can totally put 21 into that location, and therefore number of probing equals to 1 as well. The next operation would be 17. So now 17 mod 8 will equals to the index of 1. So what's happening is that originally you already have 9 over here, you have 21 over here. When 17 mod 8 equals to 1, you will get this location. It will found it is occupied. So what do? We simply look into the next available location. So when that's happening, you will be able to see that 9 is over here occupied. So you look into the next available location. So the next available location will be index of 2 and see it's available over there. And therefore, we can put 17 into that spot. So this is the idea of using open addressing, because you can see there's still many open spaces. So we try to use the available locations and store the values right next to the home position. That's what we are calling for. So what is the home position? Home position indicating the value after the hash function. What is the original location that you want it to be? And after that, we try to store 18, and when we try to feed 18 into our hash function, 18 mod 8 equals to 2. So now we will see 17 is already occupied, so we look into the next available location that gives you the location of 3, and it is available, so I can put 18 over here. You can see that both operations that we have just recently see takes number of probing equals to 2, because they look into the home position, finding it's not available, and then when you try the next location, it is there. And therefore, I want you to think about this. When I try to store the value of 81, 81 mod 8 equals to 1. So when that's happening, the home position would be the index of 1. It is occupied, so you will look into the next location. It is occupied as well, look into the next location, occupied, look into the next location, and therefore 81 will appear over here. And of course, number of probing equals to 4. And that's what we have seen so far. And therefore, if you're understanding correctly, store, which means that we put the elements in, is pretty straightforward. And therefore, if we want to look for some item, for example, if I'm searching for the value of 17, well, what's happening is that if you try to do the search, you will map 17 into the hash function, find the home position equals to 1, understanding that 9 is not 17, so I will be able to look into the next location and find 17 over here. And it will be the same thing if you're looking for the value of 81, you will map into the home position of 1 and then keep looking until you find the value of 81. One special scenario I want you guys to think about. So saying that if I want to search for the value of 1, 1 mod 8 will equals to 1, and therefore you will look into the home position. This is not 1, you will look, this is not 1, this is not 1, this is not 1, this is not 1, until you look into this location. It is null, and that is when you will understand 1 does not exist in this array, because if 1 is there, you will see a 1 over here instead of a null. And that is how we will be able to find that the value we want to search does not exist. That is a very important idea, because when we comes to the next idea, next operation, which is delete, you will see a big important operation over here. Take a look at this one, delete 9. So saying that I want to delete 9, which means that after 9 map into the hash function, we will get index of 1. We will be able to find 9 immediately. So think about this. If I simply delete 9, what is happening? If I simply delete 9, and while we try to search for 17, it will map into the home position of 1, finding out it is null. And that will give us a big trouble, because we do have 17. And if we simply delete the items that we want to delete without doing anything, the search operation would fail, because the logic that we had is based on there is an item occupied in the home position. And therefore, take a look of this one carefully. While we try to delete operation, we can delete it. However, we need to leave a special notation. Whatever sign that you want to do, you need to leave a special information indicating that there was an item over here. Right now, this space is available. So if you want to insert the value of 1, you will be able to find the home position, finding out this is empty. There was something here before, but it is empty right now, so I would be able to use this location. However, if you are doing search operations, such as search for 17, you will map into the home position, understanding that there was something here. Right now it is empty, but there was something here, so I need to keep looking, because 17 might be right next to it. So that is why when we do a delete operation, we need to leave a special sign over there. After that, we try to store the value of 80, and when we do 80 map into the hash function, you get a value of 0, and therefore you can simply put 80 over here. You can see the special sign still stays over here, and then what's happening is that for both operations, we've only tried once, and we will be able to do those operations. Store is 32, so the home position of the 32 is 0, because 32 mod 8 equals to 0, because it's simply fully divided by 8. And therefore, you can see that original home position will be 80. It will map over here, finding out it is occupied, so you will look into the next available location. See, it is indicating there was something here, but it is available. So if you want to take the space, take it. And therefore, we will be able to put 32 over here. We try 2 times to get the space. Finally, when we try to do the value of 81, you can see that we will be able to map into this location and then keep searching for 81 until we find 81, and we can delete it. However, remember to leave a special sign over here. And therefore, that is the idea of the linear probing. Just look into the next available location. Very straightforward, very simple. It's probably designed for human mind to look into this one. And therefore, I want you guys to have some assignment, have some practice. You see that this operation over here is indicating you would have the 10 spaces over here. I just noticed that this is something not correct, so let me correct it. You will be able to see this one. So basically, there are 10 spaces. Instead of 8 spaces, there are 10 spaces over here. And I want you guys to look into the operations thinking that if I want to store this information, delete this information, doing these kind of things, how would you fill in the table with the right positions for each element and as well as the number of probes over here. So this is something I want you to submit. You can simply use the PowerPoint slides that downloaded from the Blackboard and use this table to write the code, or you can copy and paste or whatever you want to do. It's going to be your choice, so that for the assignments, I would like to see this full table with all the operations being done. And let me continue with the linear probing to go a little bit deeper here. Now you already know how you would be able to fill in the table. You're probably thinking the assignment is piece of cake. It's pretty simple, pretty straightforward. But more importantly is that how would you tell the computer to do it? So let's take a look at what's happening over here. The linear probing, if you have noticed, there is an equation I have not touched yet until now. So what this linear probing trying to do is this one. You will have a full completed hash function. What it try to do is that you try to look into the value you want to deal with. Either is a store operation or a delete operation or a search operation. So you have your key. The I over here, you can think that as a I loop. Starting with 0, indicating when I is 0, that is your home position. And therefore, you will try that. The beginning, you will feed your k value into the hash function, find the home position, plus I equal to 0. So you will not do any change, but search for the home position. If it is occupied, so think about this. This is a while loop over there. If the value is not processable, I will increment from 0 to 1. That's how you will be able to look into the next location. So you see home position plus 1. That's exactly how many times you have tried. If your I equal to 1, you try once, it's not there, so you need to look into the next location. If the still not available, you can look into 2 spaces from your home position. And that I is the control for you to look for the next available location. And that's what's happening over here. You may have question, why there is another mod m? Because that mod is already existed in the hash function. Think about this. This mod operation is trying to help you to do the following things. Basically, you see that if you have some home positions mapping in here, 7, and that is not available, how would you look into the next location? Your value will have that home position plus 1, get one more value. So you need to give you the capability of wrapping around. That's the circular queue idea. And therefore, we would have to do the mod one more time in case that you need to look on the other end of the array. And therefore, you can see that there are like 2 mod operators over here to help you go through the process. The first one is your hash function. The other one is the one that help you to look into the probing, find the next available location. And therefore, take a look of this one. The same example that we have introduced. Starting from store the value of 9, we will feed 9 into the hash function over here. I was starting with 0, so that I put the equation over here. And therefore, you can see that when h90 equals to h of 9, we will feed the hash function k equal to 9, so 9 mod a equals to 1. 1 plus 0, because this is our first time of the try, equals to 1. 1 mod 8. We don't need to wrap around, so it does not matter, and therefore you will look into the value of 1. That's how the computer would know to look into the index of 1, thinking it is available over there. Now you see the store 21 is the same thing. You're feeding 21 0, h of 21 equals to 5 plus 0, we are not changing anything, but look into the home position, 5 mod a equals to 5 is not changing. The only thing that it will change on the last mod is that when the value equals to 8, then it will become 0. Same thing with the circular Q idea. So while we try to store the value of 17, it will start with 17 and 0. After the hash function, you get a value of 1. 1 plus 0 mod a equals to 1. It is not there, so what's happening is that we will need to continue by doing h of 17, and now you can see the I changed to 1. So in your while loop, that need to increment by 1, and therefore you will have h of 17 plus 1. So original home position is 1. 1 plus 1 equals to 2. So you will be able to look into the index of 2 and therefore finding that is available over there. Same thing with 18. You will start with 18, 0. Getting the home position of 2 is not there. So I increment by 1. Look into the space of 3. Finding it is available. When we try to do the store 81, starting with 81 of 0, it is not available. Getting the index of 1, then we need to increment by 1, get the next location, then we get the next location, finally we get the location when I equal to 3, we find this value available in here. And you can see that the I is totally correlated to number of probing. That's what's the idea of the probing used in the programming. So when we try to do the delete operation, same thing. We feed 9 into the hash function. Home position equals to 1. Found it, leave a special sign over there, move on. Store 80, same thing. 80, 0 equals to h of 80 plus 0, so that you will find the index of 0. The next one, 32, the same thing. Starting with the home position, not there. Look into the next location. So basically, you will be able to see it's available over there. Finally, try to search of the 81. It will follow the same pattern that you store the value of 81. Found it, leave a special sign, and that is what's happening when the computer is trying to do the hash function in linear probing. This equation can have some modifications. So for example, you can see that the I we're starting with 0 and then increment by 1. The corresponding change in here is the same thing with I. And there's many different ways that we can handle it. For example, we can set the equation equals to h of k plus 2i, 2 multiply I. So in the beginning, 2 multiply 0, we still get a 0. We were still hitting the home position. While we see that it is not available, instead of looking to the next location, it's totally possible to tell the computer to look into 2 positions after the home position for the first try. If it's still not there, 4 positions. If it's still not available, 6 positions. So you can easily control how would you want to search for the next available location. This is another example of the hash table with linear probing. The special thing over here is that I want to show you not only the numbers can do the hash function, the characters can do that. So you can see this is the hash function over here. It simply say when the character is AP or Q, you will map into the location of 0. If the character is B, O, R, it will map into the location of 1, etc. So that when we try to store A is mapped into the hash function, finding the home position of 0. So we will put A over here. It will be the same thing for A, C, D, G because they are all do ones and find the right position. When you try to store P, it will map into the home position here, finding it is occupied, so it will store in the next location, and then the number of probing equals to 2. Store Q will map this home position, not available, not available, not available, not available. Finding is available over here, so it has 5 operations. Delete is the same thing. Delete P will follow the same process of the P, so you will start looking into the index of 0, look into the next location, found it, leave a special sign over here, and then we will be able to do the following process, following the same thing. You should be able to understand this easily. It's just give you another flavor of different hash function over here. So choosing a hash function. Notice that the insertion of Q requires several probes. So you can see that what it's trying to talk over here is this one. When we start mapping into the home position, because they are consecutively occupied already, so that's what we call it forms a cluster. And therefore, whenever you hit something in between the cluster, you will need to step one by one until you find the space outside of the cluster. That links to what I have mentioned a little bit earlier, indicating that instead of looking into the next available location, you can say I want to look 2 positions after. And there are some different, many different changes can be made. That's why we have linear probing, quadratic probing, or even double hash functions. The performance of the hash table depends on having a hash function that evenly distributed the key. Choosing a good function is always not that easy. You need to have a lot of tests and try to find the best way of solving so. The clustering is what I am talking about. The clustering, the position of an initial mapping is what we call the home position. While several items hitting on the same home position multiple times, it forms a cluster. And the cluster is not something nice because it will slow down your operation. So as the cluster grows, the probability that the key will hit the cluster increase, and this cluster can go bigger and bigger. As this cluster grow, it's totally possible to merge with another cluster that are close to each other, and now it will actually end up with bad performance. And therefore, there are some other methods that we would be able to try to look into what we call quadratic probing as well as the double hashing. We will discuss about that in the next video.